Good morning, kids. Today we're going to talk about rectangle. We're going to create rectangle, talk about rectangles definition, sides, angles, diagonals, and also symmetry. So let's start. First, we need a straight edge. For example, this triangular ruler can help us. I will make my line parallel to the edge of the paper. So if I put parallel this edge to the edge of the paper, I will have very straight perpendicular lines toward the edge of the paper. And then when I create a line or line segment that a rectangle gonna build, I can choose how long I would like my rectangle one side should be. So if I take that to be, let's see, 9 centimeters, this triangle doesn't show me 9 centimeters. It says 0 to 8, but that doesn't need to stop me. So I can measure how long is to 8, and I would like extend 1 more centimeters to make that this rectangle has 9 centimeters one side. So I can take long rule if I want to check, and I can use all to make sure that I did it correctly. So here is a 9 centimeters, and we can measure. We can label these two sides, 2 points on our rectangle. And now, in order to make rectangle, you need two long sides and two shorter sides, which and also we need the right angles. To create the right angle, we can use also our one of the triangular rulers that help us to make perpendicular line toward the this line segment. So we can use make this triangle exactly on that line segment, and then opposite to it it's the other side of rectangle, which I would like to be like a 5 centimeters. So I made a right angle by using my triangular ruler, and then I can check. If you don't believe me, there is, like, if I take my paper clip, I can see that that angle is exactly fits in. So I created right angle. Um, and now I need to do the 5 centimeters that I would like. So I needed to extend my line a little bit more. Here is my 5 centimeters, so I'm going to go there. Okay. And I have two sides of my rectangle. I have a long side and I have a short side of my rectangle. And this one is, if I want to label a rectangle, I should label with a large capital letters. So this could be A, and then this point could be B. So this is called line segment AB. And I'm going to create now. I'm going to use my triangular ruler to make parallel lines. So if I need another line that is same as a line A, let's see, A, B, C, D. This would be my point D. Then I will use, then I need a C point. I can use it by making my triangle very on a parallel to AD segment. Make my other small triangle very started next to each other. Push the hand to make strong the yellow triangle, and then I can do the move my green triangle very easily with just one finger up and down, and I will create a parallel line segment that it will be my line segment BC. I will go approximately close to then I needed to be that point, and then I will take my ruler and measure 9 centimeters. So here's an 8. I actually did perfect. It's like I don't need to add more. Here is my C point, and I can just connect these two, and that will be giving me um, the other perpendicular line, a line segment toward BC. So I can make it a little bit more strong line so you can see it. And then here is the point D. We can check, and you can, as you can see, that is a 5 centimeters. 1, 2, 3, 4, 5 centimeters. So I have two 5 centimeters sides and two 9 centimeter sides. If you would like to label sides of line segment, usually we are using the lowercase letter for the sides. So, like if this is, for example, this could be an A sides, and then this will be also A sides. They are the same. And then B sides is this, and then B sides is this as well. So we have a two congruent sides. So A is equals to 9 centimeters, and also A is equal to 9 centimeters. B is equals to 5 centimeters, and B is equals to 5 centimeters. So we can also ask our students to measure in inches. So if I would like to that line segment to not be centimeters, I can do in millimeters, which will be 90 millimeters. Each centimeter is a 10 millimeters, so that could be also another. Or another idea is to use customary units, which is American. For example, if I need inches, this is 0 to 1. This is 1 inch, 2 inch, 3 inch, and then I can figure it out how many more would be that 9 centimeter. It looks like a 3 whole inches, and I can see the parts that are cut from to the fourth inch. I don't have a whole fourth inch, so I have points right here, and that is looks like 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 16 pieces that makes a whole inch. So uh, you could say that A is equals 3 whole inches and a 9/16 of the other inch. So A is equals also 3 and 9/16 of the inch. Just to and also B could 5 centimeters. That could be if I measure in inch approximately. It's a little bit less than 2 inches, because 2.4 is uh, so we can say that it's about uh, two, let me see, 1 whole inch and about 15, 16 of an inch. If we did measure correctly, of course, that would be the inches changed to the centimeters are a little bit tricky. Okay, so even less than so it's approximately 2 inches. 5 centimeters, about 2 inches, or a little bit less. We can say 1 inch and like 15 sixteenths of an inch. Or if we can round that up, we can say it's about. And if we don't, if we want to, so B is approximately, we can wavy lines. That means we're rounding. We're rounding B sides to the 2 centimeters. 2 inches, sorry, 2 inches. Or we can say that B is equals to 2 and 5/16 inch. Either way is acceptable. line segment, we also can label the rectangle as we needed to go clockwise, A, B, C, D. So if we're going to say that this is a rectangle A, B, C, D, we can say AB line segment is congruent, and this is a symbol for to be congruent. AB is congruent to CD, line segment. And line segment is just a line above the capital letters. And then we can also say that line segment AD, AD is congruent to, in the wavy line on the top of equal sign, to the BC line segment. BC line segment. We can also use a parallel line, so we can say that the AB line segment is parallel, and those are the two parallel lines upside down and vertical to the AB. AB is parallel to CD line segment. And then we can say also that AD line segment is parallel to BC line segment. Okay. If we explore, students needs to know that what in these are parallel, so if we can prove it by using our rulers, and we can see that if I take BC and I slide my ruler down to they will be matching, they never going to touch each other. And if I extend the lines, you can see that BC line segment is parallel to AD line segment. They will they never gonna touch, and they are in the same distance from each their point is the same distance on the away from AD line segment is the points are on a BD line segment. We can also prove that if we extend AB line segment, that is parallel to, and we can put our ruler exactly on a AB line segment, and if we scroll down, it will be DC line segment parallel to it. So we can extend the lines. And this time we can also discover that if we look and compare AD line segment with the BD line segment, BA line segment, that we can see that they create perpendicular lines. So perpendicular lines is a 90 degrees angle, and we can prove that each of our angles are 90 degrees angle. So we can show our students that by using a compass, the angles lives in a circle. So if I take let's use a B point. If I take my compass and let me put something underneath so it's more 30. Okay, so if I put my compass on point B, I can draw the circle around it, and trying hard. Okay, we can use our compass. We can always go back to the where we start and make a circle around it. So, as you can see, we create the right angle 4 right angles actually, because this is the how we label right angle, but then there are also one here, and one here, which we create all the circles. So what that means is that right angle is 1/4 of a circle, and we know that mathematicians use 360 degrees to define the circle 360 degrees. So we can see that this must be a 90 degrees, this must be 90 degrees, this must be 90 degrees. So the one inside of the our rectangle is also 90 degrees. And then as well as point A is 90 degrees, point C is 90 degrees, and point D is 90 degrees angle, because there are lines, segments are perpendicular to each other, and they cut the circle in 4 congruent parts, and each part is 90 degrees. Okay, usually when you see the rectangle, we turn right 90 degrees, we can see that if there is a shape like a little square, that means automatically that is considered as 90 degrees angle. So that's just good to know. And then we also can label our angles, so we can say that little tiny angle with a line across. Some people use that. So we can say that angle A is congruent to angle B, and then angle B is congruent to angle C, and then angle C is congruent to angle D, and of course that angle D is congruent to angle A, and every angle is equal to 90 degrees. 90 degrees. We also need to know that if we cut the shapes and angles in all these 4 angles will add up to 360 degrees, and will make a straight will make 360 degrees, and it will make a circle, which makes sense because 1, 2, 3, 4 of this right angles, if you look in a circle, here are these 4 that will make the whole circle, and that we can prove that. Another thing we can talk about is diagonal. So if I take my ruler and I cut diagonals, could be this opposite points, and that is we label as a D1 and diagonal D1, and then it cuts into 2 identical congruent triangles. This, and I can show you in my, I have my rulers, so they also create 2, if I look at this, that is my rectangle, and if I take diagonal through it, I will make 2 identical triangles. Okay, another diagonal is opposite B and D point line segment, and that is a D2. And those are diagonals are exactly the same. We can measure our diagonals, and we can see how long they are. Okay, they're congruent in that they are about 10 whole centimeters, 1, 2, 3, about 10.3, 10 point, looks like 10.4 centimeters. So so D1 is congruent to D2, diagonal 2, and that they both equal to 10.4, 10 and 10 whole centimeters and 4 more millimeters. So we can use 10 and 4/10 of the centimeters, next centimeter. Or we can say 104 millimeters. So if we see that we didn't label a perpendicular line segment, so we can see by extending these lines that a line segment AD, is perpendicular, and upside down T is perpendicular symbol for perpendicular lines or line segment. So if we extend the lines, we can see that AD line segment is perpendicular to the BA line segment or AB line segment. Okay, we can see that BC line segment is perpendicular to AD line segment. So BC line segment is perpendicular to this CD line segment is perpendicular, or BC is this one. So BC is perpendicular to CD line segment. And then we can see that CD line segment is perpendicular to AD line segment. Okay. CD line segment is perpendicular to AD, DE line segment, DA line segment. Okay, and then AD is perpendicular to BC, so we already have that one. We can write a definition. So how we can conclude is that rectangle is first quadrilateral, which means it has four sides. Quattro means four, quadrilateral, four lattice are sides, four lattice, four sides. And also rectangle is a parallelogram with four right angles. Okay, if we talk about and distinguish rectangle with sides, we can say that there are four sides. And then the opposite sides parallel. Parallel and congruent. And congruent. Okay. And if we talk about angles, well, we can say that it has four right angles. Four right angles. And we can make 90 degrees on a side so that students know that it's 90 degrees. If we talk about diagonals are congruent, and there are two diagonals, two congruent diagonals. And we can explore symmetry. We have a line symmetry and rotational symmetry. So for a line symmetry, we can find a midpoint that will cut the shape into two congruent pieces. So I know that this diagonal, well, where diagonals meet, that is a midpoint in between 4.5 centimeter and 4.5. And then these two parts are identical, and this is a line symmetry. So we can extend if we want that line in a little dashes, and we can put L1. That's one line of symmetry. We can also look at the 2.5 centimeters, where is half 2.5 here, and here 2.5. It will cut horizontally this rectangle into two identical parts, and that is going to be line symmetry 2. So this is L2. So we have a two line of symmetry, um, two line of symmetry. Okay. If you would like to explore rotational symmetry, we use like a paper that it's see-through, and then I did already copy this rectangle, and then we put a dot on the top of the line segment that we would like to rotate, and then we can rotate the shape. And if it gets into the same position, it has rotational symmetry. So if we go slowly and rotate around the midpoint, we can see that it stopped and it's matching into the same shape this way, and our point is on the bottom. So if we go and keep rotating, it will come back to the starting position. So we stop twice to get to the whole 360 degrees. So this rectangle, every rectangle has um, it has a two rotational symmetry. Two rotational symmetry. Okay. We also can prove that our line of symmetry. So right here, this is my one of the line of symmetry, L1, and if I fold it, it will perfectly fit into the half, and we can say that this is one of the line of symmetry. Also, we can have the second through horizontal cut into half of the rectangle, and then we can see that is exactly matching the half of the rectangle so that is the second line of symmetry. Okay. Um, so far, thank you for listening. I hope you like it. And this was a story about rectangle, properties of rectangle, how to label, and I hope you learned something from me. Thank you.